All right, okay, good afternoon. Welcome to the IAS Distinguished Seminars offered by Professor Carlo GHEZZI. So Professor GHEZZI received his PhD in 1969. At the same year, the term software engineering was also proposed, exactly in the same year. In Garmisch, I think. Yeah, in Garmisch. And after that, Professor GHEZZI served a lot of important positions, including the editor-in-chief in TOSEM, Transition on Software Engineering Methodology, Transition of Software Engineering, TSE, and he has served on the editorial board of Communications of the ACM and Science of Computer Programming, just to name a few. Professor GHEZZI's contribution made a significant contribution in our area, including software engineering and computer science. And he is an ACM Fellow, an IEEE Fellow, a member of the European Academy of Sciences, and also a member of the Italian Academy of Sciences. During 2012 to 2015, Professor GHEZZI was the president of Informatics Europe. He received many prestigious awards, including the Distinguished Education Award from the IEEE Technical Committee on Software Engineering in 2018, the Outstanding Research Award from the ACM SIGSOFT in 2015, and the Distinguished Service Award from the ACM SIGSOFT in 2006. So without delay, I will pass the mic to Professor GHEZZI, who will share with us reflecting on the digital revolution from a historical perspective to a call for actions. Thank you, Professor GHEZZI.
Thank you very much for the nice introduction. I am very glad to be here with you in Hong Kong today. As you can see here, I will be here for a month in Hong Kong as a visiting professor at the Computer Science and Engineering Department, and as a senior visiting member here at the Institute for Advanced Science. So I'm very glad to be here, and I would like to welcome all of you to my talk. I want to make my talk, if possible, as interactive as possible with you. So if you have any questions at any time, if you have any comments, if you want to disagree with what I say, or if you want to agree, and you want to provide further arguments on what I say, you are very welcome. I would like to start, though, with something that is not strictly related with my talk, which shows where I come from and where I am today. And you can see some difference here. This is definitely much older than on the left-hand side than what you see on the right-hand side. But this is a technical university. It's considered to be the best technical university in my country, in Italy. It's one of the top engineering and architecture schools in Europe. And this is, of course, what it is. This is the Hong Kong University of Science and Technology. And here, just to give you a glimpse, of also the differences of the cities in which, my university is located and your university is located. One is definitely much more modern, and the other one, is rooted back. I mean, this cathedral, they started building in the 13th century, and they kept, building, most of the cathedrals in Europe. They took centuries. People continued to work on them and revise their design and their look. So, very different, but but we have a very different past, but maybe we have a not so different future. And just to give you an idea of the future which is already here, this is what I left. When I left my country, there was a very bad weather, with wind that we never expected to have in Europe. There's extreme weather, manifestations increasingly. So there's climate change, which is affecting all of us, and it's making, my, home situation very similar in some sense to what used to be in more tropical areas, like Hong Kong. So trees fallen there and destroying a car. And this is a picture. So this was a picture that I took in July. And this is a picture that I took in September here on campus in Hong Kong. OK, so this is just, as a way to start this seminar today. But let's be, more to the point. So what are we talking about today? So I want to tell you a little bit of, what you can expect me to say today. Well, first of all, I want to make a disclaimer. This is not a very technical talk in a sense, but it aims at being a kind of reflection of where progress in digital technologies and what we normally call IT, progress in digital technologies has led us, and what is the role that we need to assume increasingly because of that as scientists, as engineers. So that's basically my aim. Okay, so understand where we are and what is this asking, professionals to do. So the talk is basically divided in two parts. One is looking backwards and one is looking forward. Okay, looking backwards means that I want to give you a historical understanding, a historical view of what happened and why this has generated what we call the digital revolution today. Why are we here? Okay, so and in particular, to look at the progress, the scientific progress that we had, and the consequential societal and cultural changes that technology has produced. Okay, so but what I want to show is what makes the so-called digital revolution special. Which are the main technical constituents? Why it has been so changing the world, if you want. And eventually, I want to lead you to the point at which I really believe that the ultimate component that is responsible for this revolution is software. So software is the key driver of the digital revolution. And then looking forward. Looking forward, what I want to discuss with you is who should drive the technological progress which leads to changes that are affecting all of mankind. So these are changes that are not restricted to specific areas, but they are affecting all of us. Who is responsible for that? The people who develop technology? Just them? Second question. Wait, actually, sorry. The same question is, should this progress be driven just by us, by technologists, and driven just by purely technological motivations, given the fact that they are affecting our life so deeply? if you want, how can instead technological advances be directed towards development of, the United Nations? If you look at the opening page that they have in their program, the United Nations is calling for an open, free, and secure digital future for all of us. Okay? So if this is the goal, and I feel represented by these words by the United Nations. So if this is what we aim, how can we direct advances in this direction? And in the end, basically, I want to then focus on two more limited questions. We are, I have been, now I'm retired, I'm an emeritus professor, so I don't have direct responsibilities. But the people who do research and education, what kind of responsibilities do they have with this respect? Okay, so this is basically what I'm going to talk about. All right? So looking backward, which is the first part. Well, first of all, I would like to point your attention to something that relates to philosophy of science. So philosophers have been reflecting on how science progresses. Okay? And in particular, there has been a very important piece of work, an important piece of work done by a philosopher, Thomas Kuhn, who published a very important book in 1962, which is called The Structure of Scientific Revolutions. Okay? And by the way, this is the most cited book ever in social sciences. Okay, so it's an important contribution. And what Thomas Kuhn says is that science and technology, the progress of science and technology is not linear, okay? But it undergoes periodic revolutions. Revolutions are also sometimes called, and actually this is attributed to Thomas Kuhn, but it's not true. This is sometimes called paradigm shift. So a revolution, something that is not in continuity with what was done before. So science and technology undergo periodic revolutions, then followed by period of more incremental work. So there's discontinuity points, and then there's slower progress, then discontinuity point, further progress, and so on. This is the way science progresses. So for example, at the beginning of the 20th century, when Einstein, developed the relativity theory, or when, other progress, for example, in quantistic physics came out, they were discontinuity points with respect to the past, which gave rise then, to incremental research in those areas. Okay? So that's what happens. Now, it turns out that it has also been shown that revolutionary changes in science lead to revolutionary changes also in society and human life. So humans change dramatically because of those revolutionary changes in science. Okay? And in fact, just give an example. This is a very small, if you want, but revolutionary change in technology, which is the invention, in the mid 15th century by Gutenberg of the printing, machine printing, using movable metal type. Okay? What people did before to produce books was to do them manually. Okay? But Gutenberg invented, and this has been a disruptive change, a revolutionary change. Why? Well, because, there was no way of producing mass production of books before. And then immediately, with the invention of this machine, you could produce, mass production. You had mass production of books. And this had a dramatic change on human life. Why? Culture, before that, transmission of culture was much slower, was filtered by people. Okay? So with the production of books, humans had direct contact with culture, not mediated by priests or by other people, as it happened before. This, for example, the first book that was produced was the Bible. Okay? So, mass production of Bible given to people. And this led to a revolution in religion. Because, for example, I'm talking, this is a very European, if you want, phenomenon. Okay? But I think it's very important because before that, there was only the Catholic Church. With the mass production of Bible, there was the Reformation. So changes in religion, changes in political structure in Europe, wars because of differences in religion. So you can say that a discontinuity point, a revolution in technology, led to revolution in society, so to dramatic changes in society in the way people think. Okay? Okay, of course. Now here, we are interested in the digital revolution. Okay? So now let's stop, with the analogy, with books. Let's look at the digital revolution. The digital revolution occurred in the mid-20th century, right? Last century, after the Second World War. Okay? And it occurred already in a society which is called the industrial society. So at that stage, we can say that, the situation of society was the industrial society, right? So, and the industrial society was generated by the so-called Industrial Revolution, which goes back to the the Industrial Revolution. The Industrial. The Industrial Revolution took place, in about 3 centuries, from the 18th to the 20th century. So in 3 centuries, we had the Industrial Revolution, which, then turned into the digital revolution. But the Industrial Revolution itself has been generated by a revolution in science. And the revolution in science is what is normally called the scientific revolution. So the scientific revolution occurred at the beginning of the 17th century. This revolution in science led to the Industrial Revolution. So let's look a little bit at this before we go then to the digital revolution. Okay? So the scientific revolution is the mother of all revolutions in modern age. Okay? We can say that mankind has been evolved after the after the scientific revolution in a way that is perhaps more dramatic than what happened in all the millennia before. So the scientific revolution has been really the mother of all changes. Okay? So what is the scientific revolution? The scientific revolution basically is the invention of the scientific method. And the invention of the scientific method, goes back to, a number of people. And here I'm naming a few of them. Francis Bacon, Copernicus, Galileo, Descartes, Newton. So these are the people who developed the scientific method which we use today when we do science. And what is the scientific method? In a nutshell, the scientific method is based on the fact that, if you want to understand a phenomenon, you do empirical observations, then, you produce a tentative theory which explains what you observe, okay? Then you do validation of your theory through further empirical observations, and then you refine your theory. You get a better and better understanding of some phenomenon. Okay? This is, in essence, this is the scientific method. Okay. As I said before, what happened in 500 years after the invention of the scientific method, which is from, the end of the 16th century to today, there has been a phenomenal growth of human power which was never experienced before in the previous millennia of the history of humankind. So progress, in these 500 years, basically humans lived in the same way, until 500 years ago, more or less. And then, with the invention, if you want, of the scientific method, there has been a complete change. So there has been the development of sciences which proved to be the main source of human power. And if you want to understand more of this, I truly recommend you to read this book. This book is a book that, sold as a 1 million copy, a bestseller book, okay, by an Israeli historian, Harari. This book is called Sapiens, A Brief History on Humankind, and really shows you, the fundamental importance of the invention of the scientific method for the progress and the changes then in society. So, why this happened? This happened because, before that, what humans called science was by and large beliefs without justification. So it gave the foundations for modern science. Okay? And the pillars of the scientific method, as I said before, is the fact that you admit your ignorance. So you know that you don't know certain things. And you accept that what you think may be invalidated by further observations. So you may believe in something, but then if you observe something that is not consistent with your theory of the world that you have up to that point, you have to refine or revise your theory. Okay? And the other essence of the scientific method, so as I said, is the centrality of empirical observations and reliance on mathematics to formulate theory. So that has been the major, contribution of this type of work. So the scientific revolution then led to the industrial revolution. So as I said before, disruptive changes in science lead to disruptive changes in humankind, in society. So the scientific revolution, especially in the area of mechanics and thermodynamics, led to technological inventions and innovations, which led to the industrial society. The revolution started mainly in the UK in the middle of the 18th century. So it was the most powerful industrial country. So a new word was defined. The previous word for millennia was based on agriculture, on craftsmanship, on commerce. Because of the Industrial Revolution, the new word became the new word of machines and factories, of new kinds of work and life, working in companies, in factories. They didn't exist before. And this led to huge societal changes. Society moved from a feudal society to a society based on, bourgeoisie and proletariat. People living in the country became people living in cities where factories were located. It was dramatic changes in the life of people. So changes in science lead to changes in humans and in society. So of course, every change produces lots of opportunities, but also lots of threats. And the same is happening today. So the Industrial Revolution, I might skip something, but basically what produced was the notion of machines. The Industrial Revolution produced machines. Machines because of, new materials, iron, steel, new source of energy, coal, steam engine, then later electricity, oil, combustion engine, and the invention of machines. So machines liberated humans from a lot of physical work, right? And so on and so forth. So let me skip some of these comments here. Now, IT revolution. The IT revolution started with the invention of digital technologies. And this was at the end of World War II, past century. And what is happening is that the digital revolution is generated unprecedented changes. I want to convince you, you are living in this continuous flow of change, right? But if you stop for a little and you look backwards, you will realize, how dramatic the change has been and is going to be. Okay? Because what's happening is that with digital technologies, we are not just producing machines. We are producing machines also, and I will talk about this. But actually what we are doing is that we are generating a completely new world in which we live. It's a world that we can call a cyber-physical world. A world that is physical, because we live in a physical space, but also there is another space which is in continuity with the physical space, which is the virtual or cyber space. And the two worlds are increasingly connected. So it's a new world. In this world we live, but other entities which become more and more autonomous live also. Okay? And we live in a new space and time dimension. Because we are in space, we are virtually in all the space on Earth, which wasn't there 20, 30 years ago. So the IT, what I want to briefly now discuss with you is that the IT revolution compared to the Industrial Revolution is even broader. So there's a difference in breadth. It is broader. It is deeper. Okay, and it is and it happens at a much higher speed. So there's 3 dimensions: breadth, everything is affected; depth, everything is affected in its essence, not for superficial things, but in the essence. And everything is happening at a speed that is uncomparable with the speed we had before. The Industrial Revolution took 3 centuries to realize. The IT revolution is taking decades. Okay? And humans are not so adaptable. So we change slower than the changes that are happening in technology. Okay, so I want to very briefly now, because I guess that all of you know this, but I want to very briefly, have you think what are, why is digital technology affecting everything in terms of breadth, depth, and speed? And we look at the main technological components of the digital revolution. The first is digital machines. The second is networks of digital machines. The third is digital interaction among humans and the physical world, so the way we interact. The fourth is agency, is software. And as I said at the very beginning, in the end, we will see that actually the heart of everything is here, is in software. And when I talk about software, of course, what's happening here is that software is moving from automation to autonomy. That's the key aspect that we need to be aware of. So software has been used so far to automate things, okay, produced by humans, okay? What's happening is that, we're shifting from automation to autonomy. So software is becoming autonomous. Machines are becoming autonomous. And that's the big change. And in particular, this is due to, what, we all know and we all read about, which is AI. Okay? But AI is part of software. I mean, it's not something magical, right? So it's part of software. Okay, and we will talk about that. So digital machines, very quickly, everything started with, roots are here, digital encoding of information, Shannon, Turing, the work on machines, and in particular, the work of von Neumann. So from 1930s, 1940, so this is the period of foundations, which led eventually to what we know today as the von Neumann architecture, which is the structure of the machines of the digital revolution. So the machines of the digital revolution are basically things of this kind. But, in a few decades, those machines evolved from this kind of machine. You have probably seen this picture before. So this is how those machines were in 1945. Huge, bulky, buggy, consuming huge amounts of energy that you would need to maintain every day because you would burn pieces and replace them. And programming was done by rewiring to, because of the of Moore's law. I'm going fast, these things. we moved from technology based on, for example, bulbs and valves to integrated circuits. And today, the power of the ENIAC machine, actually much more of that power, is residing on something like this. So smaller, faster, there's no, these things. And today, our machines, basically, if they have a physical, they take physical space, it's because of the, the keyboard, it's because of the speakers, the printers, the video, but the heart of the machine is a tiny piece of integrated circuit. Okay? And, these, I don't need to go through them, amazing progress. In decades, it didn't take centuries, it took decades. In 40 years, we moved, to this situation. Second component, I said, so machines, but machines becoming smaller and smaller, distributed, more powerful, less hungry in terms of energy. Networks. This is, again, have you ever reflected on, how change has occurred here? I was in the US when ARPANET started. Okay? I was at UCLA, when they made the first experiments connecting 4 computers. Okay? The 4 computers were UCLA, SRI, UCSB, and University of Utah. Okay, this is 1969. In 1983, the TCP/IP protocol was invented. Initially, again, mostly used in academia. But in 1995, we had 16 million users of the internet. Okay? In 2022, we had 4,000, almost 500 million users. 69% of the world population is connected through the internet. You see how fast that happens? The Industrial Revolution took, as I said, centuries. Okay? Here, 69, 22. 50 years. Networks have been brought to real people. So everybody is connected. Okay? And this has been due to mobile networking. GSM, Wi-Fi, so mass access. So just to give you, again, an idea, so this is data that you can easily find of technology penetration. So the total population is about, 8 billion. Of these, 67% of the world population is using, mobile phones. Internet users, 62% of the world population. Active social media users, 60%. And this was in 1922. Probably it is different today. So that's the, what's the change is. I said 3 components: digital machines, connected digital machines, interaction with the world. Today, machines can interact directly with the physical world, through sensors and actuators. There's smart dust, there's smart tags, there are, mini tiny devices, tiny electromechanical systems that can sense light, movement. So, the computing systems are directly connected with the physical world. We are talking about the Internet of Things. Again, the forecast So we know that basically everything is potentially connected and accessible. The forecast is that in 2025, each human will have at least 15 things to which the person is connected. Human interaction, it started with textual interfaces. It moved to more hand, touch, optical, audio. Today, we moved from digital assistant to interaction with digital agents. So it has been a huge change in the way we interact with these machines. There's even examples in which interaction is occurring at the physiological level. Nerves in our body that are directly connected, with the external world. There's even, brain-machine interaction, which means that, we're connecting the electrical phenomena occurring in our brain, interpreting them to connect with machines. So this is all true, but the real nature of the revolution is software. Because through software, digital machines are universal machines. So the fact that, if you reflect a little bit, the difference between the Industrial Revolution and the digital revolution is that in the Industrial Revolution, each machine was able to do one thing. Okay? The machines of the digital revolution are universal machines that you can program to do anything. Right? So, and this is because of software. So universal machines need software. So software is what leads to the depth and breadth of the digital revolution. Through software, all aspects of human life and society are affected and redefined. As I said, new dimensions of life and society are brought to life. In a sense, through software, we are defining a new world where the physical and the digital and the cyber are seamlessly blended. Again, if you look at software, the evolution has been, from machine able to compute, and the first real big success of computers was, helping landing the man on moon, doing computations that humans could not do by hand. But computations are fine. But then machines became, machine used for automation in any field, from industrial automation to banking to education to entertainment to whatever. And now, as I said, autonomous machine. And machines are becoming autonomous through learning because machines are able to learn. This is the key to autonomy. So there's a paradigm change in our machines, again. And this is, again, a discontinuity within the digital evolution. Because, the paradigm change is from humans creating machines, which is what has happened so far, to machines creating machines. Right? And self-evolving machines, and machines that can evolve themselves without necessarily humans doing it. This is what's happening today, right? It's happening because, if you look at the way, today we can use learning techniques, to learn. Today, we have, as we all know, we have deep learning algorithms that can be, through examples, they can be trained. And they can be trained to learn a function, a computation, to learn a machine, if you want. And so what's happening is that, you know, the desired computation, the desired function, instead of being programmed, is learned automatically by a machine. So the desired function is the result, and then you can use the application. So here, you know, this is a machine producing a machine, right? And further observations can refine the machine, can evolve the machine. So, oops. Sorry. Yes. No. I don't know what's happening here. Okay. Yes. And in fact, you know, today we know that there's cases where you can generate code automatically. You know, ChatGPT. You know, the big revolutionary change. You know, something that, you know, came out at the end of last year. You know, came out this conversational version of you know, the so-called generative AI models developed by OpenAI. So, and GPT is a so-called generative pre-trained transformer. It's basically a large language model based on the innovative combination of unsupervised training and reinforcement learning from humans, and can be used to automatically generate program. I don't know how many of you, but there has been a discussion, you know, on communications of the ACM. Communications of the ACM is, you know, the main journal of, you know, computer science professionals. And in January, it published a paper titled "The End of Programming," in which, you know, this guy claimed that we will not need anymore to train people to program, because machines can do. Then, of course, this was a very extreme position, and a month later, there was another paper called "The Premature Obituary of Programming," okay, in which says, well, you know, wait a minute, yes, but the point is that, you know, even something that, you know, people didn't dare say before, that in the future programs can be generated automatically, okay? Actually today, I don't know, how many of you have tried to use ChatGPT to generate program? Okay, and you know, it's not too bad. You know, still, there may be lots of problems, but, okay? And what will happen in the future? Well, this is, I think that nobody knows, right? But definitely, at least, you know, people start saying that if humans will not be out of business, they will need, however, to be able to use these tools in their generation of programs. Okay, so it will change the way people do software development. Okay, so now step back a little bit. So software is the key component, which is what enables the digital revolution. There is no question. Okay? And there has been a very interesting book, actually more than 20 years ago, by Lawrence Lessig, who is a professor of law at Harvard University. Okay? And he wrote a book in which he says that, code is law. Code is law. So what does it mean? So what he realized is that, the world in which we live today and the rules according to which the world works are defined by software. Whenever you interact with any administration, with government, with whatever, it's done through software. So the rules of what you can do or you cannot do are defined by software. So what he says is that software code is law. The law of the laws, the rules according to which the world works are defined by software. Have you ever thought about this? This is a real strong statement. So code is the law of the world. The laws according to which the world works are defined by software. They are enacted, they are executed by software. So software has a pretty strong responsibilities, right? Because it's the ruler of the world, of the new world that we are creating, this cyber-physical world, which is dominated by software. So if you want, in a sense, designing technology becomes the same as designing the world. So we are designing the new world, the way it works, in software. Okay? Now, if this is true, most of the software is actually opaque. We don't know exactly, how it works. And especially, with the use of AI-generated software, this is even more opaque than before. And this is raising some concerns, right? So if it is true that software has such a key role in the world in which we live, but this role is played by a technology that is often, can only be interpreted, by the way, by a small minority of people. So it's out of the democratic control of the mass, of the people, right? And in some cases, we even don't know how it works. So AI-generated, you probably know that AI-generated software, AI-learned functions are almost impossible to describe. Why do they work in a certain way? You probably know that this idea, this topic of explainable AI, so being able to explain why a certain learning algorithm has produced a certain function, this is still an open research area. Okay? So we're giving so much responsibility to this technology, but how much, is this right to do? So looking forward, so we start. I think we all agree that there's unprecedented, tremendous power of digital technology on humans, society, the world. This is true. But this is giving unprecedented responsibilities to this technology, because everything depends on this technology. So, designing technology is designing the world, as I said before. So the question, let me go back to the question that I posed initially in my presentation. I have about an hour, right? Okay, so I can, okay, but then I would like to also maybe discuss a little bit. So, since designing technology is designing the world, how can we direct technological advances towards the development of an open, free, and secure digital future for all? You remember I started by mentioning this United Nations declaration. How can we? How can we maximize the benefits that digital technologies can bring while curtailing the risks? And the real question is, how can we, humans, drive the process to ensure that progress is for our good, for the good of all of us, not the good of a few, the good of all of us? I think that these are important questions that we as technologists have to ask. So the road in front of us, I came to the conclusion, and I'm more and more convinced by the fact that if what I said so far is true, and you agree, digital technologies are so important that they cannot be left only in the hands of digital technologists. They should not just be left in our hands. What do I mean by this? I mean that, we need to include more other people, other kinds of knowledge into the discussion. It's not just a question of technology. Because technology is affecting our lives, and we have to understand how people behave, how we can, help people, how we can help society. And technologists don't really understand that. So we need to open an interdisciplinary debate with others, and we have to enlarge and build a more global community of people around these topics. So just to give an example, this is an initiative in which I started working. It's an international effort, which is the so-called Digital Humanism Initiative. I will show you a little bit, of what's behind this group of people who are collaborating on this topic. But it's a place, it's a group of people in which these topics are discussed and which bring together people from different areas, from computer science like myself, but also from social sciences, from political sciences, from humanities, and so on. So this, let me actually show you by navigating briefly through this website. So this is a group, the website is maintained at the university in Vienna, a technical university of Vienna, and it's called the Digital Humanism Initiative. So it says the Digital Humanism Initiative is an international collaboration seeking to build a community of scholars, policymakers, and industrial players who are focused on ensuring that technology development remains centered on human interests. And just to show you a few activities, what we have done was creating first a manifesto on digital humanism. Digital humanism is the term that we have used to describe what we intend to do. we intend to understand the relation between digital technology and society and humans, and make sure that developments of digital technologies are for the benefit of humankind. There's a manifesto, there's a roadmap, there's a lecture series, there's workshops. If you're interested, you can participate in those lecture series, listen to lectures. They are recorded there's a YouTube channel in which you can find all of them. Well, just to give you an idea, the steering committee, I'm one of the members of this steering committee. Other people that, people here knows is Professor Jeff Kramer from Imperial College, who is also in computer science. Professor Jim Larus from EPFL, he was the dean of EPFL in Switzerland. Edward Lee, UC Berkeley, Moshe Vardi, Rice University, and this guy Hannes Wertner from Technical University of Vienna, who has been basically the main coordinator of this working group. So there's a number of people who is part of the steering committee of this group. But as I said, one of the things that, for example, produced was a book, which is called Perspective of Digital Humanism. And just to show you, and now I close this, but as I said, you can explore the website. I can leave, the pointer in my slides, and I can leave the slides so that you can see them. What I want to show is that this book that we produced, which is a collection of essays which touch the different aspects that we think are relevant for digital humanism. And this book, let me go back to the slides, here is published as an open access book by Springer, so you can easily download if you want. What is interesting is that I wrote several books in my life, but I never got to about 400K people who accessed my books, which means that I think that this topic is felt as an important topic by many people. So the book has been, as I said, is open access, so it's been, downloaded by about, 400,000 people. So it had quite a, pretty good, it was, considered to be interested by quite a number of people. So I think that, and this is in 1 year, basically, that it has been published. Okay, so I think that it covers a topic that many people think is important. So, digital humanism, as I said, how does it affect us? It affects us as citizens because we are citizens in the digital world, and this is affecting our individual lives, democracy, social justice, sovereignty of our nations, but as professionals also. Okay, so now I want to briefly conclude with a few comments on what is the relation between digital humanism and academic research and education. Okay, what I think is the relation. Education, first. I believe that our education is far too much enclosed within rigid disciplinary silos. Our knowledge is compartmented too much. Okay? So technologists, so the people, for example, I've been a software researcher for all my life. I never spoke, I never talked to social scientists, human scientists, regarding the software, the goals that the software you develop should satisfy, the requirements that it should fulfill, the way you can validate it, I never thought, about the need that the software actually has to satisfy certain values that are human values. So I've never been talking to, human scientists or social scientists, and vice versa. And these people ignore technology. I think this is wrong. Because technology spans over all of these areas, people from different areas, they need to talk to each other more than they used to. And this is first consideration. Second, well, more precisely, I think, we need to make computer science curricula more aware of the human and social implications of the technology that they are focusing on. Students should learn more about ethics. Not only code of ethics for students, but ethics in the profession and general ethic values. Ethics means that people should think more about what is good and what is bad for people, for society, for the world when they develop technology. Again, if I think backwards to what I've been teaching for many years, I've been teaching how to make programs more efficient, more portable, maybe, more extendable, okay? But have I thought of, making programs more useful for people? Helping, for example, making sure that the software that was developed wouldn't discriminate among people? So I never thought about the possible values for humans that software was embedded and needed to be understood before developing software. So I would say that students have to know more about that. Not only, but they have to be encouraged to take more courses from humanities and social sciences. And this is my dream. I believe university is kind of a lab for life for me. So you learn something that then you want to bring into the real world, life. Okay? So within the university, students have to learn, collaborate with students from other disciplines. So now, in most universities, people do labs. So they develop things in labs, right? But in labs, do they ever sit with students from other disciplines? No. At least in all the cases I know. Do you ever have students from social science sitting together with you when you're developing a system in which there's a social component in the software that is being developed? Okay? So mixing students, in labs so that people start understand each other. Of course, here I'm talking about computer science, but it is true, the same is true, for people from other disciplines who should know how to interact with us. So, yeah, why am I saying that, having lab exposure, so thinking when you develop systems, I think that, we need to understand when we design a system, and students have to learn that they have to anticipate what are the human social consequences of the software that is being developed. How will this affect people? can this affect people in a bad way or in a good way? So you have to start introducing, while you develop systems, understanding the good and the bad before the software goes out. When it's out, it's already late to introduce, to regulate, to limit, to change. Okay? So what I want to say that we should try to introduce as much as possible in the design of the systems some what I call ex ante, means before analysis of the social human implications of what is being developed, instead of just developing technology and then put it in the real world. Okay, and I think that this is very important because innovations spread very rapidly. So if you spread something, we have seen, that, for example, just to give an example, could social media, we all know, for example, we have seen cases in which Facebook, for example, has been used and has produced, so-called echo chambers, in which people thinking in the same way, they reinforce their opinion about something. There's hate production. It has been used, to spread fake news, to influence in a bad way political behaviors of people. Now, could this have been taken into account when the social media was developed, to take countermeasures to avoid certain types of possible misbehaviors? Maybe not, but maybe yes. Or maybe, at least, some kind of pre-warning about possible bad uses could have been issued before spreading, in a certain unrestricted way the technology. So what I'm saying is, can we anticipate this type of discussion? And we can anticipate only if we bring other competencies to the table, more interdisciplinary type of interaction. So research is the same. So research is also compartmented by disciplinary silos, and human and societal goals and concerns are often ignored. The question is, can they be brought to the table? And of course, I don't have an answer here, but it is something that I think requires more and more attention from us. So, of course, we don't want to throw away the baby with the dirty water, right? So we want to keep technical depth, but at the same time, we want to broaden the view, okay? So can we, keep technical depth and combine it and perhaps even enrich by human and societal concerns? Well, again, I already said this, typical design goals directing technological research have been, cost reduction and improved efficiency. Should we instead ask questions about what is right and good, what is bad and wrong in education, in requirements, to assess alternative solutions, to validate, verify? We have never, spoken. We have never discussed, verification, validation of our systems, with respect to, wrong and good, in the ethical considerations. Okay, let me stop here. So basically, that's the stage at which we are. I hope that, I convinced you that, what we are doing is key for society. The technology we are developing is key for the world that we're building, but we need to broaden the discussion on what we are doing, and we need to take into more and more consideration aspects that we have largely ignored as technologists, but they are crucial for humans and society of the future. Thank you very much.
Okay, let's thank Professor GHEZZI. So we have time to take questions.
You may also say that you disagree.
Yeah, thank you, Professor, for your wonderful talk. So as you said, we should talk to, as a technological researcher, we should also talk to maybe human researcher in humanity and social science. But I just wonder how we can motivate ourselves to do it, because as a researcher in technology, we have many KPI to fulfill, like we need to publish paper, we need to apply patent, and we need to focus particularly on the technological problem. So I just wonder, in real life, how can we motivate ourselves to talk to people that out of our expertise domain? Yeah, thank you for your, thank you for that.
Mm-hmm. No, I do not have any recipe, right? But I have, examples in which I have seen that this works. I see several cases in which technologists, so people, technical people, work together with philosophers. For example, there's I have seen, in my university, in the mechanical engineering department, where they do, self-driving vehicles, they hired also philosophers who are raising, ethical issues regarding, the effects of automation on, of automatically driving vehicles, and they are working together in understanding, how this can improve the way you approach automation in driving, by taking into account, the ethical responsibility of the person who is in the car, with, the fact that the machine decides. There's many cases in which there's design decisions that you can make in designing the way this interaction occurs, in which, having someone who is an expert more on ethics can pose or can the right questions to the person who has to make certain decisions who are technical. This is one example. But I have seen, for example, there is a research group which is working on developing, a software design methodology which is based on agile methods, in which they incorporate what they call ethical deliberations, which is a discussion of features in which you discuss about what is good and what is bad. And what is good and what is bad is for humans, for example, when you're designing a new system, what is good and what is bad is always some kind of discussion which is not black and white, because there's nothing that is, don't do that. There are cases, but this is the law that tells you you cannot do certain things. But sometimes there's pros and cons, and you have to, get the contribution in understanding what the goals you need to set. You need interaction with people who are expert in ethics and not in technology. So they are incorporating what they call ethical deliberations in an agile process. So there are cases, and I think another example, there are people who are developing, testing techniques for software in which you are testing for fairness in the case of systems who do automatic decisions, because these systems can be biased. They can be biased because the training that has been used to produce a certain decision system led the the software to be unfair, for example, minorities or certain kind of people. Now, the question is, so there are technical questions here that you are raising, but you reach the point in which you formulate the technical question through some kind of interaction in which you are taking into account considerations that normally, as technologists, we didn't ask ourselves. As I said, talking about efficiency or talking about functional correctness of something, yes, it's a question that we always try to ask ourselves. But understanding, is this fair? Does this discriminate? Is this going, to affect, some, way of thinking of young people in a bad way? So these are, I think that, we need to develop research goals and a research agenda which is more based on these questions, or at least also brings these questions to the table. And we didn't do it in the past. Sorry for the long answer. But it's a long question also because I have no answer really, but I have some. Sorry.
Okay. Let me guess. I think this is a talk about the humanity talk. Is that right?
Yes.
Okay. I thought that is about the perspective of the AI. Okay. So I look at okay, before I come, okay, I look at the title. Sounds very interesting to me, so I came right here. Okay. But now, okay, you raised many ones. Okay. I just get an experience. One of my students, okay, used ChatGPT to modify a paper about an introduction. But I modified several times. When I looked at it, it looks quite strange. Okay, very strange. I think that is bad. Okay, it's but that's a technical paper. Okay, I'm from the math department. Okay, that's very technical, and ChatGPT cannot do that well. Okay, but for ordinary, okay, like for a human, okay, or humanity, okay, or social science, okay. If a student need to hand in a term paper, okay, write down a popular topic, and they can use ChatGPT can write a very good term paper. And I think that it becomes a disaster for the teacher, okay, for the professor to judge, okay, to grade these kind of term papers, okay. Okay, that's kind of okay, the bad things. Of course, there's good things, okay. And another one, okay, the basic question, okay, this is not what I want to care. I want to care is that, okay, about the digital world, okay, about the, okay, we have the physical world, the reality, okay, and another one we have from doing mathematics. We have a mathematical world, okay. We're using numbers, real numbers, not digits, not the rational numbers, okay, to build up the whole world. Okay, that's different. That's called a mathematical world, very accurate. Okay, but that's a design. That's an ideal world. Okay. Okay, how? Okay, human will have. When we receive something, okay, we'll also get a word in our mind. That's different from the mathematical world and the physical world. Okay, and now okay, with computer graphics or using AI, we have a digital world, okay. So can you make some comments about this different world or virtual realities or the different worlds, okay? Okay, physical world, mathematical world, and our mental world. Okay, the world okay, in different people's mind. Okay, and using the progress of the AI. Okay, thank you. Okay.
Okay. Well, in some sense, what we are building is something that is amalgamating all these words together. For example, as at least the physical world and the digital world, they are completely interconnected. I don't know what the mathematical word is in what you say, but the digital world and the mathematical world are not so distant, right? Because computers are, in the end, they are mathematical devices. So math is also part of this world. But definitely the physical and the digital, they are completely intermixed. Today, if you're talking to, interaction among humans, in the past would only occur in the physical world because you could hear what I would say, right?
Digital world is finite. The mathematical is infinite. Okay, so that's
yes, yes. Yes.
The digital was based on the Turing machine. Everything is created in
No,
the finite number of steps.
Yes, I understand that, but clear. It's clear, right?
Yeah.
Now, the point is that in the size of the digital world, is becoming so huge that, of course, it's not infinite. But for example, just to tell you, one thing, the time dimension in which you live today, is uncomparable with the time dimension in which people lived, 60 years ago. Even, the fact that today you are instantly connected with anybody or anything in the world, right? It is something that it was inconceivable. So right now, I am, in a sense, co-present with anybody I can reach. And I can talk to this guy, even if there's, he's sitting on the other side of the world. So the notion of space, the notion of time, have completely disappeared. Now, it is true that in mathematics you have this concept, this abstraction, which is infinity. You have
small world. This is called. In 6 steps, you can find anybody you know. In the no, you don't need to know. I mean that I think about the 3 steps in the internet, you can know everybody in the society.
Yes, but everything, not only anybody, but anything, because anything can be connected.
Oh, that's Leibniz said it. Everything is connected.
Everything is connected. And there may be, I can switch on, my light. Suppose that I have a house in New Zealand. So at this point, I can say, okay, switch on the light. Or, what is the temperature in my cellar? So I am everywhere at any time. So the notion of time and space have disappeared. They're completely different, right? And a child today, in my case, I still don't understand it. It's not part of my brain, but, you should think about, what is in the brain of a young guy who starts living today in a world in which these notions of space and time are, the ones that, digital technology is giving us. Now, you talk about the mathematical world, and yes, but, we haven't, it's not the notion of infinity that you have in mathematics, but we have a notion of scale of things which is.
Okay, never mind. Okay, it's about that means the rationality, rational numbers, and irrationality, irrational numbers. That's real numbers, of course. Them okay.
Of course,
that's
yes.
different. That's
of course.
It's past the finiteness.
Yeah. Yes. It's not the continuous.
It's not okay.
It's not a continuous word, but I can make it as close as I can to this continuous word.
Okay,
I can approximate as much as I can your real numbers, if you give me enough bits.
Okay. Thanks. Comments? Okay. Any further questions?
Hi, Professor. Thank you very much for your presentation. I think I have a solution to the students' question there, because my research interest is in data visualization, and also actually in one of the field, HCI, is also do exactly what you're promoting right now. We talk about human and computer, how do they interact, and we keep human in the loop in order of our softwares that we design. We ask domain experts to do a design study. Our field, they value the contribution of domain characterization, which means that you turn a fuzzy task, which right now everyone is encountering, is not like an AI. You can just have a definite benchmark and also a definite task, just do prediction, push up all the accuracy. It is not like that. If you have a fuzzy task, then domain characterization is valued in our field. But one of the questions that I have for your presentation is that you said when software are used by a lot of people, then we are placing a lot of responsibility on them. But in my understanding, the word responsibility only happens when we care about somebody. Like I have responsibility for my family, for school, and something like that. But for programs and machines, they're not like humans. They don't have responsibilities.
They don't have, but you create them, right?
Yes, so it is the person who has the responsibility.
Yeah.
So, but then it connects to to the next part, is that are we software engineers the sole person who needs to bear this responsibility, or the people, or the companies, business partners?
Sure.
They are the one involved too. So, if you're talking about software engineers, should bear in mind these ethics, but we are tasked with building more advanced, just like ChatGPT. You're just tasked with generating the AGIs, then what you can do. You don't seem to have a solution for that.
That's a very good question. You're quite right. So first of all, the responsibility is on, those who create the technology. It's on those who produce the technology to be put in the real world, on those who use the technology. So there's a responsibility is collective. Also, there is a responsibility in people using. The point is that we should clearly understand that there is a responsibility first. That it is mine, it is yours, it is his. And then, there has to be awareness and also an agreement on how to share this responsibility. Today, there's responsibility is nowhere. So what I'm claiming is that we should face this problem, that there is the need to take responsibility. Each actor for part of it, but it has to be shared, and it has to be a kind of common effort, to understand how to share this kind of responsibility. But the point is that there is. We cannot just ignore.
Yes, okay. Thanks, Professor GHEZZI. Okay, we have time to take one more question. Okay, so maybe I take this liberty to have the last questions for Professor GHEZZI. okay, in response to questions raised by the audience, okay, for example, okay, let's say nowadays we have many large software companies, okay, and let's say if I were asked by our software companies to design our solutions to evaluate the performance of the programmers, right? So we kind of need to think about the humanities and the responsibilities, and probably not just I myself need to consider these responsibilities, and also the company who use my solution to evaluate the performance of programmers. And also, let's say this kind of solution also take advantage of large language models and reference the data on the World Wide Web or connected elsewhere or pre-trained by somebody, or even the process of doing alignment of the large language models, the one who collects the data set to pre-train this large language model. So there sounds like there are various parties that, let's say, just a company, a software companies, want to develop a solution or ask me to develop solutions to evaluate the performance of programmers, so that the company would decide whether to their salary, to adjust their salary, or even whether some of them need to be redundant. Nowadays in United States, many companies chose to redundant some programmers. So what are your comments on that?
Well, I'm glad I'm a retired professor, so they will not ask me to do this. Well, if you're saying, if you're asked to do to develop something which has a whose possible use is something that may be for the bad of some people. Well, if you have the option to decide, I wouldn't do it. But
I mean, they can be constructive. Let's say, the company may use these solutions to improve, to let the program to improve the productivity, or it could be destructive.
Yes. Well, of course, very often, you can say that the technology that we develop has a so-called dual use. So it can be used, for good purposes. It can be used for bad purposes. Now, I think that, well, first of all, at least your responsibility is to try as much as possible to make this explicit, which is already a very important thing. So make it explicit that this technology can be used to to achieve this, but can be used also to achieve that. Okay? So awareness is the first important step. Now, everybody then knows that, there's this danger. Then you can say that the use, is in the hands of somebody else. So that would be my answer. So make an explicit statement about the potential dual use of that technology.
Okay. Yes, we are now in the areas of challenges. I would say more to come, and thanks Professor GHEZZI to bring up a very important issue that we need to consider. okay, in future, either okay, we after graduations or work in the industry, or okay, we are being consultants, or we are okay, set up, okay, start up our own companies. All right. Okay, thank you.
Thank you.